Topic 5, Objective 3, write the polynomial function if given the roots. So now we're going to work backwards. We have been given polynomial functions in standard form, and we've solved them and found all of the roots, both imaginary and real. And now we are going to be given real roots and imaginary roots and work backwards to write the polynomial function in standard form. It will include multiplication. All right. Does that make sense, right? Because in order to solve for them, we've had to divide them. So now we're going to multiply them back together. Before we do anything, though, we have to talk about what's called the complex conjugate root theorem. And just FYI, I'm only going to do the first example in this video because it involves all real roots. In the next video, I'm going to do the next problem because this one involves imaginary solutions. And this is supposed to be 2 and then minus 2i. Alright, so please cross out that problem and put that instead. Actually, in the spirit of doing that, if you would turn to the next page for your practice, I needed to change some things as well. And so would you change number 2, number 4, and number 6 to what I have written in blue? So number 2 should be the solutions -4, 2i, and 3. Number 4 should be the solutions 3 and -2i. And number 6 should be the solutions -3 with a multiplicity of 2 and then -3i. Alright, so please cross out the ones that are given to you and write what's in blue instead. That's what you're going to be solving. Now, to begin, again, we need to talk about the complex conjugate root theorem. What this means, if you see if you see an imaginary solution, so for example, bi, where b is any whole number, real number. If bi, and I is the imaginary piece, if bi is a root, then its complex conjugate, -bi, is also a root. So you need to be able to recognize, especially like if you look at number 2, that should jump out at you. There's an imaginary solution, -2i there. If that ever exists, then its complex conjugate also exists. All right? A couple more examples of those, just to put it in number form. If I have a solution of 5i in this polynomial that I'm working with, then I need to recognize that its complex conjugate, -5i, also exists. All right? In a couple other formats you can see that in, especially from the quadratic formula you've been working with. Let's say it's 3 minus 4i. I know that the complex conjugate of 3 plus 4i also exists within that polynomial. And if you notice, I don't change the sign of the whole number or real number 3. Those always stay the same. The only thing that switches is the sign of the imaginary piece. It went from -4i to complex conjugate +4i. And up here it was a +5i. I had to include the negative version as well of that imaginary piece. Alright, so that being said, anytime you see an imaginary solution, know that its complex conjugate also exists, and you need to write that and work with that as well. Alright, I'm going to do number 1 as an example. I'm going to work it out and then ask you to do number 1 down in the bottom left as well. So, first thing I notice is that it gives me solutions. It says 3 multiplicity of 2 and then the solution of 2 as well. Another format we've seen that you should be more familiar with is just 3m2, 2m1. They didn't write the m1. Again, if it's ever a multiplicity or a power of 1, you don't necessarily have to write it. So it is given to me in solutions. I have 2, well, no, never mind. I have 3 solutions because 3 exists twice because of the multiplicity of 2. So in solution format or root format, the first step in order to do this process, in order to find the actual polynomial in standard form, is to write in factored form. Alright, so if I take step 1, I'm going to write it in factored form. I know that if it's a positive solution, it's going to be an x minus format in factored form. So if it's a +3, it's going to be x minus 3 to the power of 2. And then, again, power of 2 because of the multiplicity of 2. And then since it's a +2, I also know that it's going to be an x minus 2 to the power of 1, which I don't have to write. And you should know that anytime it's written in factored form, when parentheses are next to each other like that, all that means is it's multiplication. So that's going to be the next step. Step 1 is I wrote it in factored form. I'm done with that. Step 2 is now I start to multiply. All right. This step is going to look different based on if they're real solutions or imaginary. In this case, they're real. And it just depends on how many solutions exist. All right. Will determine how much multiplication you have to do. So, in this case, there's going to eventually be 3 binomials I'm going to have to multiply together, and I made note of that. The first step I would take in doing that is you multiply 2 binomials together to get a trinomial, and then you multiply the trinomial with the binomial. That's the process I'm going to show. And then I made stars. If there are factors with imaginary pieces, you multiply those together first, but that won't come into play till the next video. And then when I'm all done multiplying, I combine like terms, which is a skill we've used before, and then I write in standard form. So the first thing to do for this multiplication piece is I recognize that this power of 2 means that there are 2 x minus 3's that exist. So I have to write them next to each other like that. All right, and then I didn't touch that x minus 2, so I'm just going to drop it down. Now at this point, it doesn't necessarily matter what 2 binomials I start with. I'm just going to do the x minus 3's first. All right. I'm going to show my thought process out again, and if this helps you, then I would encourage you to show your work like this as well. I'm going to do x times x, and then x times negative 3. X times x is x squared. X times negative 3 is negative 3x. Then I have a negative 3 times an x. And I have a negative 3 times a negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. At this point, I have 2 terms to combine. Negative 3x and negative 3x. And that'll give me my final trinomial of x squared minus 6x. That was a minus 6x when I combine those like terms, and then plus 9. Alright? I didn't touch that x minus 2, so I'm just going to drop it down. Now, this process, multiplying a binomial with the trinomial, is pretty tedious because there's lots of steps to utilize. So there's just lots of things to multiply back and forth with each other. So please, I would, if it helps you, please show your work like this so you can just organize your thought process. I actually use this as well because it helps me organize my thought process. So I'm going to start with the x squared on the left. It's going to distribute into the x over there. I'm going to write that, x squared times x. Then the x squared is going to also go to the negative 2. So I have x squared times negative 2. I can do that math. X squared times x is x cubed. X squared times negative 2 is negative 2x. Excellent. I'm done with the x squared term. I can cross it out if I want to. All right. Now I move on to the next left term, which is negative 6. I forgot my x. It's supposed to be negative 6x. So my negative 6x, all right, that also is going to go to the x. So negative 6x times x will equal something. And then negative 6x times negative 2. Negative 6x times negative 2. So negative 6x times x is negative 6x squared. And I'm sorry, this negative 2x is supposed to be negative 2x squared as well. I noticed because you should be noticing that there will be like terms that are going to exist as you do this, that you will eventually need to combine. And then finally, negative 6x times negative 2 is positive 12x. All right? I'm done with my middle term of negative 6x, so I can move on to my final term in that trinomial of 9. I do 9 times x. I can write that down. 9 times x is 9x. And then 9 times negative 2 is negative 18. And I'm done with the 9 as well. Now I just got to combine like terms and then write in standard form. If you notice, I have 2 steps of that. I have 2x squareds. There are no like terms with that x cubed. It's by itself, so it just shows up again in my final answer. And then I have two linear x's as well. So negative 2x squared minus 6x squared is negative 8x squared. And then, yeah, that's supposed to be a... Oh, I'm right. Negative 6x times negative 2 equals positive 12x. 12x plus 9x, because that's a positive 9x, is a 21x. Alright? I've combined all the like terms. The negative 18 didn't have a like term. Now I just have to write it in standard form. So that goes. X cubed goes first. Then the quadratic term, negative x squared. Then positive 21x. And then minus 18. And I am done. Couple things to say about this. If you notice, the highest power of my multiplication is 3. That should make sense because way back in the beginning, I had 3 with a multiplicity of 2, so technically 2 3's exist in this. And then I had 1 2 because of multiplicity of 1. So I had 3 total roots to begin with, and it gave me a polynomial with the highest power of 3. And if I graph this polynomial, it would bounce off the x-axis at x equals 3, and it would go through the x-axis at x equals 2. So please pause this video and go ahead and try that process with this example problem down here, number 1. Alright? You should have paused the video and tried your example of number 1 down here. You had 2 multiplicity of 2 and then a negative 2 as a solution. 2 multiplicity of 2 should be written in factor form as x minus 2 squared, and then negative 2 as a root should be written as x plus 2. I expanded to begin with my x minus 2's to right here, and then I did this multiplication, the x minus 2 times x minus 2, right here. That gave me this trinomial, and then I dropped down the x plus 2, and then there is my math. I wrote in red the x squared multiplication, green the negative 4x multiplication, and purple the 4 multiplication. And then I had to combine like terms down here, and in standard form I got x cubed minus 2x squared minus 4x plus 8. Please check your work with mine. If yours doesn't match that, please raise your hand and I will come by and check it.